Hey guys, Pankaj here. Welcome back to my YouTube channel. In this video, I'm going to talk about last part of NLTK. So last video we saw a chunking and chinking process, right? So in this video, we are going to see how to get synonyms of a given word, how to filter the antonym, and a couple of other things. Okay, so let me share my desktop. Okay, so this was the part 4 where we saw chunking, chinking, part of speech tagging, okay, and named entity recognition. Now in the part 5, which is going to be the last part of NLTK, we are going to see what is WordNet, how to filter synonyms and antonyms, and how to find the similarity between two words. Okay, so that is also a very famous question in the interview. This can be asked also. Okay, so let's install all the library as usual. So we'll be installing NLP, word tokenize, send tokenize, port HTML. Okay, it is there, but I'm not going to use it today. Okay, let's check the version. That is 365. Sample text as usual. So I've taken Albert Einstein from wiki page. Okay, so now let's see how to get the NLTK Corpora. Okay, so Corpora is nothing but it's a huge database of speech related stuff and some rating related stuff. Okay, so I think in the last video also I showed you, but let me show you today also how to do that. Okay, so we have from NLTK dot corpus import. Let's say there is some topic called Gutenberg, right? So I'll just install. Okay, so looks like Gutenberg is not existing. There is looks like some typo. Yeah. So Gutenberg is there. So once you install it, there could be so many different topics, right? So I think I have already shown the folder. If not, then if you remember, I have given the path where all the list of corpora will be listed, right? So Gutenberg is one of them. Okay, then how to read it? So let's say I'll just mention t1 equal to Gutenberg dot raw. Okay, so yeah, so it will go to that file and read the whole content and just list out. Okay, content may be big, so what I'll do, I'll just read it. And under Gutenberg there are a lot of topics. Okay, so one of the topic is like Bible kjv.text. Okay, so let me just give the topic name, Bible kjv.text. Okay, so I think it will print now. Yeah, and just to make it simplicity, because it is very huge content, right, it may make things very slow, so I'll just take t2 equal to maybe some part of a sentence from t1. Okay, so maybe first three content, print t2. Okay, this is not taking, so what I can do, I can just take maybe t1 will sentence tokenize. So a lot of sentences are there, so let's tokenize it. Okay, send using send tokenize of t1, and from t2 I'll take maybe first three sentences. Okay, so let it load. Okay, so if you want to print them for s in t3 or t2, colon 3 print sent. Okay, so this is my first sentence, second and third sentence. Okay, so that's how it looks like. Okay, so that's how you read any corpora. Go to any topic and just read it. Okay, and process tense sentence by sentence or word by word if you want. Okay, so now let's see the next topic, that is WordNet. So WordNet is what? It's a very big collection of all the synonyms, antonyms, and definition of any given context of word. Okay, so you need to understand the syntax of WordNet. Whenever it returns, right, it will return in this form. So let's say one example, we have one word called survey and followed by dot and followed by POS. So POS is nothing but part of speech, right? So we saw like noun, verb, adverb, adjective. Okay, so a lot of short form will be there. So N stands for noun. Okay, and 01 is nothing but this number. It stands for NN. That is nothing but a sense key, because one word can be can have different kind of meaning, right? And each meaning will be referring to one context, right? So based on the context, what is the sense of that word? Okay, so that is what is sensitivity will be mentioned in the form of 01 or NN. Okay, so this is what I have written here. A sense key, a word can have multiple meanings or definition. Therefore, survey.n.01 is the first noun because it is part of species noun, and 01 is first. Okay, so first noun sense of the word survey. Okay, so similarly, I'll show a couple of other examples also. You will see noun.02, noun.03, like that. There can have multiple senses. Each senses will be defined with different number. Okay, so to get synonyms and all, we have one module called WordNet. Okay, so go to NLTK.corpus, import WordNet. Okay, so now let's find all the synonyms of different senses of word called good. Okay, so I'll just mention sin equal to WordNet. We have something called, under WordNet we have sin sets. That is nothing but set of synonyms of word called good. Now let's print sin. So it will find all the context of that good and find the meaning of that, and it belongs to, let's say, now this is the complete list of synonyms of that particular word good. You may think of commodity, how come it is related with good? There could be some context. Right now I don't have exact sentence on what sentence basis it has taken commodity as close match with good word, correct? That's why, so commodity, so good noun 01, 02, 03. So good is again a synonym of good in different context, and context, there are three contexts, that is 01, 02 and 03. Okay, similarly commodity, from different context it has come to close match, that's why it is giving, it belongs to noun and their number is 01. Okay, similarly one is referring to adjective. Okay, then S, I don't know what S stands for, but A is adjective and is for noun. Then we will have something called R is also there. Okay, R, I'm not sure. Okay, so we can find out those word meaning also. I think in the last video I've shown you how to find out. Okay, so this is the way to find the synonyms. Now let's see, get lemmas of one meaning. Okay, so there could be a lot of meanings, right? So how to get the lemmas? So now we got the sin. So what we can do, iterate over each synonyms. For S in sin, print S dot lemmas. Okay, so that is their lemmatization of that particular word. It is getting printed. Okay, so if you see, the couple of words are having two lemmas. Okay, again based on different context. So we have like good, then goodness also. Okay, because lemma will always maintain the dictionary root word, right? And different context will be there. That's why good is also present, goodness is also present. Okay, similarly we have so many different words, right? So here good and as some number, then serious, sound, salutary, honest, undecomposed. So you need to really understand all kind of possible sentences or different contexts. Then only you will understand why this particular meaning has come with close match of the good word. Okay, so now this is the way to get it. And if you want to get little more detail about lemmas, right? So what you can do, so what we can do now, we can find out at least every word is having one word, right, in the form of lemmas. So what you can do, take at least one word, okay, from 0, because everything is list, right? So list, at least it contains one word. Now from 0 I can take just the name, right? So what I can do, under this we have an attribute called name. Name is a function, so it will return the name. You can see all the synonyms of good. Okay, so in case you would like to just process only the name, then you can just filter like this. So let me have it separately so that you can just play around. Okay, so to get the meaning of each synset, how to get the meaning of it? So what we can do, we can have something called definition. So sin, let's say 0, what I have here. So from this sin I'm taking, we have complete list of synonyms, right? This. So I'll just take the first one and get the definition. Let's see what we have. It is just giving benefit. Okay, so why it is returning benefit? Let me see if it has some help. There is no help. Okay, that's fine. Now let's go to the next one to get the example of that meeting, that meaning. Okay, so what we can do now, so we can get the examples also, right? So let me just get the example. So sin dot 0 dot example. There's no example, then sin, so sins dot definition, then what I can do, sin dot examples. Why? Oh, okay. So 0 is not going to work. Let's iterate over it. For s in sins print s. Okay. So from s, I can get the example directly. S dot example or examples. I think it is examples. Yeah. So for each synonym, right, whatever you got here, we can get the example also. Then probably you can understand why noun it has been taken and the sensitivity of that noun is 0, 1, 0, 2, and 0, 3. So now you can get the definition here. So for your own good, what is the good of worrying? There is much good to be found in people. Okay, so of course once you understand the context, then you will understand, okay, why it has been taken as a noun and there are different sensitivity. Okay, so that's how to get the, that is the way to get the example of one particular synonyms. Okay, now let's see, once you get the synonyms, right, how to filter synonyms and antonyms from lemmas. Okay, so there is a separate example. Let me just show you now. So we have direct function, like the way we are getting example definition. Similarly, we have antonyms also. Okay, so there are a lot of things like antonym, hypernym, synonyms. Okay, so if you really understand those things, right, probably you can just give the dir of that particular lemma or the synonyms, and you'll find all kind of names, hypernyms also. So you just get and understand those details. So filter synonyms and antonyms from lemmas, right? So what I'll do for s in sin s dot lemmas. Let me just print. So is it lemma or lemmas? Double M, right? Sorry. Okay, now we got the lemmas. After that, what we can do for each lemmas, right? Under this, what I can do, sin dot lemmas, right? So since lemmas is also, it consists of list of words, right? So for L, that is nothing but lemmas in s dot lemmas, print L dot, let's say we can print the definition also, right? We can get the examples also. And there is something called, let me just take a look what and all it contains, and I'll just break it. It does have a lot of details. So we have causes, count, language, member holonyms, member meronyms, name is there. So of course name I have already shown. You can just extract the name of that particular lemma. We'll see once again. Then we have synset, then hypernyms. Yeah, this is what I was looking, antonyms. Okay, so let's find out the antonym of this particular dot antonyms. Okay, so we are getting, not every lemma is having meaning. So wherever we see this, right, list is containing that particular antonym of that particular word, right? So only those things we can filter. So what I'll do now, instead of printing, if L dot antonyms, means if something is there, means list length of the list will be more than 0, right? So print only those n. Okay, print L dot antonyms. Okay, so we are good. So we are omitting all the empty list where uh, antonym or opposite word is not existing, right? So why to print all the empty list also? Print only those where antonyms is present. Okay, so now we got L antonyms. So what we can do now? How to get the name? Antonym dot, let's say we have directly name or not. It is not there. Then from the list I can, because it is returning as in the form of list, right? So from the list get the name. Now we got the lemma, then you print the name. Okay, so for the given lemma, that opposite word is evil, then evilness, bad, badness, bad, evil, and for well it is ill. So for which word it is giving that antonym, so let's print that also. So in this case, what I'm going to do, I'm going to print all. So for lemma L dot name. Okay, so what I'll do, I'll just beautify it. Name is this, then this dot format and dot name. I think this should be good enough. Okay, so good and antonym for good is antonym for this is this. Looks much better, right? Antonym for good is evil, then goodness is evilness. See here, it is maintaining that kind of, adjective property also. Okay, so goodness, it has maintained evilness, right? Then good is bad, goodness, again badness, and good is bad, good is evil. Then well, for well it is giving ill. Okay, see how beautifully it is returning all the antonyms. So guys, this is the way to filter all the details. Okay, antonym and synonyms. Now let's see the next one, finding word similarity using WordNet. Again, so WordNet, as I mentioned, it contains a lot of synonyms, antonyms, hypernym, a lot of different kind of detail for different contexts of given word, right, or given sentence. Similarly, it maintains the similarity also. So similarity can be, again, so let's say you are having animal name dog, right, and animal name cat. Both are not similar, but both belongs to animal, right? So they will have, or they will be returning some similarity between them. So similarity will be, it belongs to animal category, right? But they are not same, they are different, but they belongs to animal. Okay, similarly, if you compare dog with eagle, right? So again, this will also not be having very much similarity, but it may return some similarity based on like both are belonging to non-human, right? Something like that. So to find that kind of similarity, we have something called, from WordNet, we have an algorithm called Wu-Palmer algorithm. So I'm not going to talk about that formula, like how exactly it calculates. So there are a couple of other algorithms also, which I'll be explaining once I talk about machine learning. Okay, so for timing, just um, get to know how to calculate the similarity between two given words. Okay, so I'll take W1 equal to, let's say, WordNet dot synonym set. Okay, so here what it takes basically, it just take the name. So name, it should not be like just good and let's say bad. You have to give good, it belongs to which POS, that is noun, adverb, or adjective, and what is their sensitivity. So that's how you have to give. It belongs to, and let's say 0. Okay, and let's say W2 you have bad, or maybe I'll give animal name, right? That makes sense. So we have dog and we have cat. Okay, now let's print what W1 and W2 contains. So W1 is one synset and W2 is another synset. Okay, now we have something called w1 dot woo. It is wu similarity, right? So that is nothing but, as I mentioned, this is the algorithm based on Wu Palmer, right? We have Wu Palmer underscore similarity between what, w1 and w2. Okay, so see, dog and cat, it is matching almost 85%. So what you can do, you can just calculate in the form of percentage by multiplying by 100 and maybe give round 2. That should be good enough. Okay, so 85% is 85.71%, it is matching. So as I mentioned, why it is giving 85? You may think, okay, dog and cat both are different, but they are belonging to animal category, right? That's why it is belonging to animal category, and that's why match found. Okay, so we'll take similar example and see. So let's say this time I give maybe horse versus camel. It is also matching 82 because of maybe animal category or maybe four-leg animal. That could be the reason. Okay, now let's take another one. I'll take eagle and maybe rat. It is matching 72%. Okay, let's take another one. I'll just take elephant and I'll just take ant. Okay, let's see the matching between them. It is again matching with 56% because of a lot of categories will be involved, right? That's why. Let me just see good and bad, how much they're matching. Good and bad, of course they are not noun, so what I'll just put adjective. Okay, let's see how they're matching. Just 50%. Okay, because both are closely related but exactly opposite, right? I will just think another example. So what else we can take? Maybe I'll take computer, that is noun, and I'll just take dog. What is the similarity between them? Okay, it is just matching 44%. Okay, so that's the way to calculate, guys. There is one something called cosine similarity also, right? So I'll be talking detail like how the cosine similarity works and what is the fundamental concept behind that. I'll be talking in more detail with a lot of examples in machine learning classes. Okay, guys, so that's all about this, and I hope you like this NLTK video. Now in the next video, we are going to talk about Spacey library, which is advanced library for NLTK or NLP processing. Okay, so we'll see a lot of concept. We'll see pipelining concept, how the pipelining works in the text processing, and a couple of other details like what kind of language models are existing, how to use them, and what is the best way to visualize named entity recognition. In the last video, we saw NER, right? We'll do visualization as well as PUS visualization and their tree visualization, okay, in a better way. NLTK does TK visualization, which pops up the separate window, right? It makes a little hard to run the program separately and do the visualization, right? Spacey will make it very simple. Okay, so we'll see everything in detail in the Spacey library. Okay, guys, so if you would like to know a little more about some different topic, please leave your comment in the comment box. I'll definitely try to address in advanced topic of NLP. Okay, guys, thank you so much. Bye-bye.